All right, so what we're gonna do, we'll just pick it up from yesterday. We were doing some tricky things. Let's start over here. Let's start with the first one there, 20A. Question, does this 3 and log 3 cancel out?
They do.
Yeah, so this is just a one-step answer. It's 27 plus, what about that 10? Listen this. They're inverses, right? Log 10, 10 to the power of.
They cancel out.
So it's just 1027 is the answer to the first one. 2 steps, super simple. B is similar, but there's a slight trick you have to use. 5 and 5 cancels out, you get an 8. What about from the next two? What do you get? Slightly more trickier. What you need to do here is you need to use the exponent laws. If you have x to the power of a plus b, what you can do is you can redistribute this as x to the power of a times x to the power of b. If you have x a minus b, that means it's going to be x to the power of a, x to the power of a, over x to the power of b, like that, okay? You can go back and forth. You can go this way or you can go in that direction, whatever you're trying to do. So here we're in this form. I want to break this down. So look at what this becomes. This becomes 3 to the power of log 3, 5, like that, yeah? The plus there becomes times 3 to the power of log 3, 7, like that. So here we know this 3 and this 3 cancels out now, and this 3 and this 3 cancels out. So you get 8 minus 5 times 7, which is what, 8 minus 35, negative 27, and that'll be the final answer there. So remember the exponent laws. We're gonna come up with a different set of laws for logs, but it kind of builds off of this, very, very similar to those. If it's a plus, then it's times. If it's a minus, then it's a division. So now here they're asking us to find the inverse of each relation. I think they're asking us to do this algebraically. So just a quick recap, to find the inverse, what you do is you change your x and y variables. This is called interchanging the variables. So x becomes y and y becomes x. So this will end up looking like x equals 3y plus 9. And then you want to solve for your new y. So here we do minus 9 divided by 3. This right here is the inverse to this. Interchange x and y, and then try to solve for the new y. That's the idea. Let's start with the first one. Again, step number 1 is just interchange them. So y becomes x, cube root of y. How do we solve this for y? We need to do something on both sides.
You cube both
Yeah,
sides.
you cube both sides. So you get x cubed equals y. And that's it. This is your inverse. That makes sense? I'm trying to visualize what x cubed looks like. When x is -1, cube root of -1 is -1. So we start over here, goes through 0, 0. Probably will end up looking something like this. That's cube root of x. And if you draw a line here, try to reflect this. What is it going to look like? From here, well, it's going to go up. From here, it's going to go kind of like this way. And that's x cubed. Let's go to b. Now b is going to be trickier because the unknown is in the exponent. You need to use a little trick when the unknown is in the exponent. So x is equals to 3 times 2 to the power of y. How do we solve this for y?
You divide by 3.
Okay, and then
You do log.
you do log. So you'll get log of x divided by 3 is equals to log of 2 to the power of y, right?
And then y comes to the front.
Yeah, y comes to the front, and then you divide both sides by logs, and you're done. So that'll be the inverse. In fact, I'll tell you this. If you have log A over log B, the base right now for both the logs are invisible tens. What you can do is you can combine this. So the 10 there and the 10 there disappears, and whatever's in the denominator becomes the log, like that, the base. So here you can rewrite this as log base 2 of x divided by 3. And that's the inverse of this function. Keep this in mind. Log a over log b is log of b to the a. You can combine them, or you can go back and forth. This is called change of base. Let's move on to C. What do we do there? We're trying to solve, the goal is to solve for this y up here. What's the first step? If the unknown is in the exponent, if whatever you're trying to solve is in the exponent, you're gonna log both sides, right? So the answer here is just 2 steps. So log of x, and then on the other side you take a log, the y plus 2 comes out. Then you get a log of 0.5. We're trying to solve for y. This is a linear equation now. You can divide both sides by log of 0.5 and then subtract 2. And there you go. You can rewrite this as a 1 log as well. And that's the answer to part C. Did that make sense? So look at what happened here. We're trying to find the inverse. We started off as an exponential equation. We got a log equation, and we know they're the inverses of each other. D, we have a log equation. Our inverse should be an exponential equation. Let's see if we can come up with that. So x equals 3 times log 2, y minus 3 plus 2, like that. How do we solve this for y?
You subtract 2.
Okay, let's subtract 2. Let's divide by 3 as well. Now what?
You divide by log.
You can't divide by log. It's like sine. You can't divide by sine. What you do here is, like, what I mean by that is if you have sine x equals 3, you can't be like over sine, x equals to 3 over sine. Like that doesn't, it has to have an angle. Same thing with this. Log needs to have something inside of its bracket. So what you do is this. You're going to change this using this rule. If you have log base b of a equals some number c, okay? An example is log base 2 of 8 is 3. B to the power of c is going to be a. So right now this is in your log form. If you want to go into exponential form, you can do b to the power of c equals to a. And this is in the exponential form. And that's how you go back and forth between log and exponential. So using this logic here, look at what this is going to become. You see this 2? That's our base. It's going to be 2 to the power of c, so that entire thing, 2 to the power of x minus 2 divided by 3 is going to be equals to y minus 3. And then in the last step, you just add a 3 and you have your inverse. And there we go. So this rule is important to be able to go back and forth. I'm not going to graph it just yet. Any other interesting questions here? Not really. Let's go into logs rules. So these are the rules for exponentials. The rules for logs are very similar. There's just a log in the front. Here, let me just pull this entire thing up. Let's go one by one for the log rules. The base is redundant. The base can be anything. A there can be anything. So let's say you have log of 2x, okay? 2 times x. What you can do is you can split them up into log of 2 plus log of x. And whatever the base is, it's gonna come as well. So if that's base 3, then this will be 3, this will be 3. That's the first rule. Product law. The second one is the quotient. If you have 2 over x, use that formula, the second one up there. What does this become? I'm trying to use this one.
You just subtract them.
You just subtract them, exactly. So this will become log of 2 minus log of x. The third one, we've used this in our equations. If you have log of something like x squared, this is the third rule. You can bring this 2 in the front. So this is the exact same thing as 2 times log of x. So those are the 3 log rules. We're going to use these to solve log equations and whatnot. So let's go have a look at some of them. It's just algebra. It's pretty fun. It's not overly complicated. This one says simplify each log expression. Let's look at the first one. Which 3 of these rules do we use for the first one? The clue is this plus sign.
You use the first rule.
Use the first one. So we're on this side. We want to go this way. What you do is you combine the x and y. So in this case, we're going to combine the 6 and 4.5. We're going to multiply them. So this expression becomes log of base 3, 6 times 4.5, which is 27. 3 to the power of something is 27. What is that something?
3 to the power of 3.
Yeah, so the answer to this, log base 3 of 27, is going to be 3 because 3 to the power of 3 is 27. So the entire expression becomes just a 3. And you are done. What about for B? Which rule do we use?
The quotient law.
The quotient one, right? What's 42 divided by 3? Sorry, 48 divided by 3.
16.
2 to the power of something is 16. What is that something?
Two to the power of 4.
So the answer here will simply be a 4, and you are done. C is slightly more trickier, but it's going to be a 2-step answer. I don't like radicals. We're going to rewrite this as an exponent. So this becomes log base 5 of 25 to the power of what?
1 over 3.
1 over 3. And now using the third rule, you're allowed to bring the 1 over 3 in the front. Now look at this, log 5 of 25. What is that equals to? In other words, 5 to the power of something is 25. What is that something?
2.
2. So log base 5 of 25 is simply a 2. So you have 1 over 3 times a 2. The answer is 2 over 3, and you are done. Right? Just 2 steps. Not that complicated. It says graph it. they'll both end up looking like something like this. So this is a horizontal compression by a factor of 1,000. So it'll probably look like this. The other one is the same thing. It's shifted 3 units up. So that point becomes here, and it's gonna go a lot faster. The point here is not to graph them. The point here is to compare these two even without graphing them. Let's look at the first one. Log of 1,000x. We can split this up using the first rule. What does it become if we split this up? So we're using the first one there, the xy thing. So 1,000 is your x and y is your this number here. Look at this. So we have, I don't know what's x, y. This is confusing, but you can look at this as AB as well. This becomes log of 1,000, the first number, plus, because they're being multiplied, 1,000 and x are being multiplied. So it's a plus log of x. What is log of 1,000? Remember, the base here is 10. If there's no base, the base is automatically a 10, the default. What is log of 1,000?
3.
3. So this becomes 3 plus log x. So even though f and g are completely different functions, right? Initially anyways, ultimately they're the same. So if you were to type log of 1,000x on Desmos and 3 plus log x, they would be the exact same graph. Okay?
Mm-hmm.
Because we've just proved it that they are the same. Oh, this one is annoying. But it's pretty fun. Use the properties of logs to express this weird looking thing in terms of x, y, and w. If you can do this question, I think you can do any log algebra question. It just looks complicated. All you have to do is use the 3 rules here. Let me guide you. Again, no one likes radicals. We're gonna rewrite this as a exponent, right? What's the index here? 1 over what? If it's a square root?
2.
2. Can we bring that 1 over 2 in the front?
Yes.
Yes, so 1 over 2 in the front, exponent drops. Now let's look inside. We have x and y being multiplied, right? How do we split them up? If we split them up, what does it become?
You add them.
You add them. So this becomes log of x cubed plus log of y squared, right? What about the w that's in the denominator? Add or subtract?
You subtract.
You subtract. So minus log of w, and with just one more step. Because we need it in terms of log a of x. I missed all the a's, but the bases are whatever. We can bring the 3 and the 2 down, right? Because they're in the exponent now, and you're done. So the final answer will be 1 over 2 in the front, 3 times log a of x, plus 2 times log a of y, minus log a of w, and that's the end. That's it, just like 2-3 steps. Let's move on to, they open the brackets, so I guess we could open the brackets if we really wanted to. Just throw the 1 over 2 in, it's not a big deal. Let's do a couple of these, see if we can even do them. I think we should be able to, without needing a calculator. Let's look at the D, the first, well, D. What do we do here? There's a minus sign, right? Which rule do we
You
use?
divide.
You divide. So this becomes log base 2 of, can we combine them as one big root like this? The answer is yes. You can combine roots, only if you're multiplying or dividing them. Like root 2 times root 6 is root 12. Only if you're multiplying or dividing them. If you're dividing them, root 2 over root 6 becomes 2 over 6, like that. So here, 36 and 72, we're going to combine them. It's going to be, what, 1 over 2? Yeah. What do we do from here? The final answer will just be one number without logs or anything. Let's write this in the form of an exponential. So that root becomes to the power of 1 over 2. Next, I'm going to move this 2 up there. So this becomes log of 2. If I move this 2 upstairs, what does it become?
To the power of -1.
To the power negative 1. And then 1 over 2. Can this 2 and this cancel out?
No.
You can. So we can rewrite, let's write it like this. What about now?
Now it can.
Yeah. So this becomes minus 1 over 2, and that's the answer to this question. So just using log rules, nothing too fancy. E is the same thing, right? Look at how quickly you can do this. 54 times 3 over 2. There's a plus. Plus means times. 54 times 3 over 2. 2 goes into 54 27 times. 27 times 3 is 81. So what's the answer to this question? What's log base 3 of 81? It's 4, right? Because 3 power 4 is 81.
Mm-hmm.
And that's it. Just a 2-step or 3 steps. F is the same thing. Like, we just combine them. But to be able to combine them, you can't have a number in the front. Look at the formula. It doesn't have like any numbers in the front. So we have to get rid of that number, or we have to throw it somewhere else. And the only place you could throw these numbers is in the exponent. So you have log base 8 of 2. You can't really do anything with that. You have log base 8 of 2 cubed. So we can throw the cube as an exponent. And same thing with the other one. It becomes 16 to the power of 1 over 2. What do we do next?
You multiply.
You just multiply all of them. So it becomes 2 times 2 cubed times 16 to the 1 over 2. You can combine them as one big log because they all have the same bases, and it's all plus. So 16 to the power 1 over 2 is a 4. 4 times 2 is 8. 8 times 8 is 64. Log base 8 of 64, what's the answer?
8.
So it's not 8.
2. It's
2.
2.
It's 2, yeah. And that's it for that one. Anything interesting here? So for this next question, it's the opposite of one of the example questions we did before. Now it's all split up. the goal is to rewrite this as one big log. We just want one log as the final answer. So we need to be able to combine these into one big logs using those three rules. So what's the first step? If we're trying to combine them, you have to use one of the three rules.
You multiply and divide.
So before you do that, right, there's numbers in the front. You
Mhm.
can't do that unless you do something with the number. So what do we do with the 1/2, 1/2, 3/4?
You rewrite them.
Yeah, we're gonna throw it in as an exponent. So this becomes log of a x1/2 plus log of a y to the 1/2 minus log of a z to the 3/4. Now what?
Now you multiply and divide.
Now you multiply and divide. So this becomes log of a x1/2 y1/2 divided by z 3/4. And we've answered the question because we just had to have one big log. What about this one? Can we cancel out the x's?
Yes.
And then you have the answer in one step. Because then you have m minus 1 plus 1, which is an m, and you're done. Because the x's cancel out. This next question is going to be difficult. But we have learned all the tools we need to be able to answer this question. What could you do with this? We need to kind of fix this right now. We need to combine the x's, in other words. Look at the x and the root
Change the
x.
square root and you just turn that to x over 1/2.
Right, and then what do we do with the x's? I'll give you a hint. It's going to be one of these on the left up there. Now you're not dealing with multiple logs. Actually, you can either split them up. You can do both ways. I'll show you both ways. So you can use the exponential rule to, you see this, x power 1 times 1/2? This rule up here.
Mm-hmm.
You need to add the exponents. What's 1 plus 1/2?
It's 3/2.
It's 3/2. So now you can bring the 3/2 in the front, right?
Mm-hmm.
Then you have log b of x left over, and we know log b of x is 0.3. So the answer is 3/2 times 0.3. Okay?
Mm-hmm.
That's using the exponent rule up there, but you can definitely use a log rule because you're multiplying two things. You can split them up. So this becomes log b of x plus log b of x to the 1/2. So here log b of x is 0.3. That 1/2 you can bring it front, so it becomes 1/2 times 0.3. So what is it? 0.6 plus 0.3 is 0.9. And 3 times 0.3 divided by 2 is also the same thing. And you are done. Cool?
Mm-hmm.
So you can use both the rules to do this question. Nothing interesting here. Let's go to solving equations. So this is a half-life equation. Because there's the 1/2 there, it's usually a half-life equation. What do we do? How do we solve this for h? That's the question. What's the first step?
You divide by 200.
And this is not gonna be a nice number, is it? Whatever. It's 0.0625 equals 1/2 to the power of 16 over h. What's next? We're trying to solve this for h. And the unknown, which is h, is in the exponent.
You do log.
So you're gonna do logs on both sides. If you do logs, you know that exponent is gonna drop. So you get log of 0.0625 is equals to the 16 over h drops times log of 1/2. What's next?
You divide by log of 1/2.
Right, so it becomes, look at this, log of 0.0625 divided by log of 1/2. You can even write this as log of 1/2, 0.0625 only. And then you multiply, okay, actually, no, you don't multiply. Then what? So this is equals to 16 over h. We're trying to solve for h. If you want, I can give you that number divided by log of 0.5. So this is 4. Maybe this will make it easy. How do we solve this for h?
You multiply by h.
And then you divide by 4. So h is 4. The half-life of whatever this is 4 years or whatever. What about this one? Again, the unknowns are in the exponent. What would you do? There's only one thing you can do.
Log.
So to do logs, you need to have one item on the left, one item on the right. Actually, let's try it the log way. Maybe it's gonna work. So we have log of 2 to the power of x plus 2 minus 2 power x equals log of 24. So this is the formula, right? Log of a over b is log a minus log b, okay? There's no formula that exists for log of a minus b. So on the left side there, you can't do anything with it. So now you're stuck. So yeah, so that didn't work out. Let's try a different method. Log will work if you have one item on the left and one item on the right. But the fact that there's a minus sign here makes things more complicated, okay? If that minus sign wasn't there, then we could have definitely logged it. Look at 2 to the power of x plus 2. Can we split this up? How else can we write 2 to the power of x plus 2? And it has something to do with the exponential law, like this one. I want to split apart the x plus 2.
You can do 2 to the power of x times 2 to the power of 2.
Right. And here's a very useful idea in algebra. Whenever you're trying to solve an equation, if you can factor something out, do so. Can we factor anything here? Is there anything common on the left side? The answer is yes. What can we pull out on the left side?
2.
Not just 2. 2 to the power of x. This is one term, okay? 2 to the power of x.
Mm-hmm.
What are you left with if you pull out 2 to the power of x? It's the same idea as this. If you have a times b minus a, if you pull out an a, what are you left with? The same exact idea. Over here, it'll be b minus 1, because a times b is ab, and a times minus 1 is minus a. So what are we left with in the bracket up there?
2 to the power of 2 minus 1.
Right, so that's 4 minus 1, that's 3. What do we do now? We're trying to solve for x.
You divide by 3.
Yeah. What about the next step?
You do log.
You could do logs, but here's another way. You could 100% do logs. The answer will be log of 8 divided by log of 2 if you take logs. Here's another thing you can do. You can write 8 in terms of 2. So here, 2 to the x becomes 2 to the power of 3. Only do this if you can write one number in terms of the base of the other. So 8, we can write it in terms of 2. 2 equals 2, that means exponent equals exponent. The answer is 3. And you are done. Okay? That's it.
Mm-hmm.
Here's a money question. Are you a fan of money? Do you like watching it grow? This thing went from 2,500 to 4,000. And we need to figure out how long it took. I mean, that's pretty decent, right? Like,
Mm-hmm.
what would you do if you had $4,000?
I don't really know.
So it's a lot of money, but at the same time, it's really not that much of money. I don't know. Could go somewhere for Christmas break. I would do that probably.
Mm-hmm.
But anyways, let's answer the question. This is compound interest. This is used every day in banking systems and whatnot. A is the final amount. So in this case, A is 4,000. P is the principal amount, the amount that you deposit initially. So that's going to be 2,500. 1 is 1, plus I is the interest rate in decimals. What's 4.8% as decimal?
It's 0.048.
That's correct, and to the power of n. So this becomes 4,000 over 2,500. The goal here is to solve for time. So 4,000 divided by 2,500 is 1.6 is equals to 1.048 to the power of n. What do we do now?
You do log.
Now you do log, because if you see it last time it was easy because 8 you can write it in terms of 2. Here I don't even want to bother, like it's probably going to be some weird number, so you're going to log both sides. So it'll be log of 1.6 equals n times log of 1.048, and let's see how long it takes for this. Log of 1.6 divided by log of 1.048, the answer is 10 years. That's a very long time, right?
Mm-hmm.
Yeah. I mean, it's pretty decent, I guess. I think you can do better though. 2,500 in 10 years. You can make a lot with it, I think. It's a lot more with it. Actually, here, let me just show you. So what's the rate here? 4.8%, right? Let's see how much it is. Don't want to log in though. Why are you making me log in? I just want to see what the current rates are because I think in 10 years you can definitely make a lot more than $1,500.
Mm-hmm.
Yeah, it's not really showing me anything useful. There's one here. Yeah, here we go. So you have short-term ones, okay? Like this one,
Mm-hmm.
which is 4%. It says up to, so that's the maximum you could possibly earn. And you have the long-term one, 18 months, 3 years. But I know there's one that's even longer. Here, 5 years. Look at this. You can make 12%. And this is dependent upon the stock prices. So you can make up to 50%, but you won't lose any money with this. GIC means it's guaranteed. You're never gonna lose any money. You can make 12. 5, 5, 5, 5, 5 was the highest percent. And this is just one bank. So this one is looking pretty interesting right here. This one will definitely make you way more than $1,500 in 10 years. 10 years is a long time. Let's look at this. There is only one thing you can do. Actually, there's two things you can do here. You can straight up take logs because you have one item on the left, one item on the right, or you can split them apart first and then take logs on the next step. I'll show you both ways. I'm going to split it apart here. This is using the exponential rules. I'm going to log both sides on this side. So the first step here would be 2 to the x times 2 equals 3 to the x times 3 to the negative 1. What do you do next? The goal is to solve for x. Group up like terms, right? Now we have x's on different sides of the equations. Let's bring them to the same side. I'm going to move the 3 to the left, or actually let's move the 2 power x to the left. And you know 3 power negative 1 means 1 over 3, right? So I'm going to rewrite that as 1 over 3. I'm going to move the 1 over 3 to the left side by multiplying both sides by 3, so you get a 6. Like that. Here, 3 over 2. Can I combine them? They both have an exponent of x. Am I allowed to combine them?
Yes.
Yes. Same thing as a square root thing. You're allowed to combine them. Now what do you do in the next step?
You do log.
You do logs. That's right. So you have log of 6 equals log of 3 powered whatever. So x will be log 6 divided by log of 3 over 2. So that's one way. Let's look at the other way. The other way, what we do is you straight up log on both sides because you have one item on the left, one item on the right. I think this one's slightly more complicated. So it becomes log of 2 to the x plus 1 equals log of 3 to the x minus 1. We're allowed to bring the exponents down like this. What do we do next? What would you do? There's only one thing you can do, I think, is open the brackets. Let's open the brackets. Look at this. X times log 2 is x times log 2. plus, what's the next term? We're opening the
Log
bracket.
2.
Just log 2, exactly. On the other side, we have x times log 3 minus log 3. Same idea as before, group up the like terms. That means bring the like terms to the same side of the equation. I'm going to move this to the other side. It becomes x times log 3 minus x times log 2. And I'm going to bring this to the other side by adding log 3 on both sides. So it becomes log 2 plus log 3. Now on the right side, what do you see? Can we pull anything out? Do they have anything in common on the right side?
X.
X is right. So you do x times log 3 minus log 2 on the right. And then you divide both sides by that bracket and you'll have the answer. So that means the final answer of x is log 2 plus log 3 divided by log 3 minus log 2. So let me plug that in. Log 2 plus log 3 divided by log 3 minus log 2. That gives me the exact same answer of 4.419. And we are done. So there's two ways to do this. I think the left one is a little bit easier because you're allowed to group up the x's, like in this step. Makes things easier because you're only dealing with one term that has an x. On the other hand, on using this method, you have two different terms with an x, so slightly more complicated, but they both work. So let's look at D. I'll give you a hint for D. 6 power 4 is 1296. How do we go about solving for x in question D? Here's the trick. Can we write 36 in terms of 6? See that 36?
You do 6 squared.
Yeah, you do 6 squared. So it's 6 squared, and then you multiply, actually, I'm just gonna write it down. 6 squared, 2x plus 4. And on the other side, you see that 1296?
Mm-hmm.
That is 6 to the power of 4. I'm gonna bring the square root inside as well, like that. Now let's open up the brackets. You get 6 to the 4x plus 8. On the other side, you get 6 to the 2x. Do the 6's cancel out?
No.
Yes, they do, because base equals base, right? That means the exponent equals the exponent, like that. You can get rid of the bases. If you really
Okay.
want to know, okay, so here's what we're doing. We're not canceling them out. What we're doing, that's just a little bit difficult to visualize. We're taking log base 6 on both sides. That's what we're doing. So you do this on the left, you do this on the right, and you see this and this cancels out, right?
Uh-huh.
That's why 4x plus 8 is 2x. That's what we're technically doing, but you can also look at it this way, that, well, if the base is the base, that means the exponent must be the exponent. You don't have to do it this way, but this is what's happening behind the scenes. And then you subtract 2x on both sides, subtract 8 on both sides. From here, it's easy. X is -4. And you are done. Cool?
Mm-hmm.
That's it. What do we do with E? The 7. What can we do with the 7?
You subtract it.
What's 71 minus 7?
64.
So we have 2 to the 2x plus 2 is equals to 64. You could use logs here, but can you write 64 in terms of 2?
2 to the power of 8.
2 to the power of 8. I don't think so. 2 to the power of 8 is 256. I think it's 2 power 6. Let me double check that. 2 power 6 is 64,
It
yeah.
is.
Yeah, 2 power 8 is like 256. So now the base is the base. That means the exponent is the exponent, like that. So 2x equals, from here it's easy. This is like, yeah, whatever. What would you do with f? Here's a hint. You can rewrite all three of those numbers as something to the power of. How can we write? It's 3. You write all of them in powers of 3s. 3 power 2, right, for 9?
Mm-hmm.
Like this. What about 81? 3 power what is 81?
3 to the power of 4.
Mm-hmm. What about 27?
3 to the power of 3.
Right, so 3, and then there's an x, so it becomes 3 to the power of 3x. Right now you can't cancel out the 3's. You can only do that if you have 1 on the left, 1 on the right. What we need to do is we need to combine the 3's on the right side. If you use the exponent law to combine those 3's, what do you get? Use the first exponent law.
3 to the power of 4 plus 3x.
That is correct. Now can you cancel out the 3's?
Yes.
Yes, so this becomes 4x plus 2 equals 4 plus 3x. X is what, negative 2? Yeah, and now you're done, easy. So you don't even have to use logs there. A bacteria culture doubles every 15 minutes. What's our growth factor? If it says doubles, well, it's going to be 2, right? Doubles. So here, what's the question asking us? You want to tell me, what is 20? You have 4 options. 1, 2, 3, 4. NT is the final population. N0 is the initial population. T is the time that has passed. And D is the time it takes for it to double.
It's N0.
So 20 is N0. 163,840 is your NT times 2 to the power of T. I think that's the question, how long it's going to take. And the time it takes to double is 15, like that. How do we solve this equation for T?
You divide by 20.
Right, so it's going to be 163,840 divided by 20. That is 8192. Now, I think this number, you can write it in terms of 2, but we're not going to bother with that. What's the next step?
You do log.
Yeah, you do logs. It's actually 2 power 13, so, but you don't have to know that. Log of this is equals to t over 15 times log of 2. So you get log base 2 of 8192. When you divide by log 2, it goes in the denominator, right? Like this. You can write this as 1 log with a base of b. Whatever this is becomes the base. Equals t over 15. And then you multiply that by 15. 15 times 13 is 195. So therefore the answer is 195 minutes. So look at this. You start out with 20, right?
Uh-huh.
In a little over 3 hours, you have almost 100, nearing 200,000. So look at how fast they grow. So in a course of a day or two, you'll have millions and billions. Kind of brings back to this question here. Let's say you have two options. You won the lottery. The first option is that you get $1 day one, $2 day two, $4 day three, $8 day four, like that, for a month until day 30. And whatever, you get to keep all that money. The other option is you get $1 million today, you get $1 million tomorrow, you get $1 million third day up until day 30. Which one should you pick? I'll tell you the answer. This one's gonna add up to 30 million. This one's gonna add up to a little over 5 billion. So you're gonna go with this one. You can double check this by typing 2 power 30, and you'll see that how big of a number you get down here. So you wanna go with this one, okay? This is called geometric, the rate of increase, because it's multiplying by 2, and this is called arithmetic, because you're just adding the same thing over and over again. So that one's thumbs down, this one is thumbs up. Go with this one, and let's call it a day there.
Okay, thank you.
See ya.